we will start about optics. So in previous class I discussed what is the nature of light. Light is an electromagnetic wave and it can carry some amount of energy. First, at AD 1600, Newton proposed his theory that is called corpuscular theory. What it tells? It tells that light has some teeny colorful particles, and we know that the minimum distance between two teeny particles should be a straight line in a plane, in a particular plane. So from this theory we can say that light can travel in a straight path. And second one, as we know that light has teeny colorful particles, so we can say that easily we can see or we can observe different colorful light. Green, yellow, etc. After this theory, Fermat proposed his theory that is called Fermat's principle or Fermat's theory. According to Fermat's theory, light should travel along this path where the traveling time of light should be minimum. So we can say that del of t should be equal to 0. That means what is this t? T is equal to the time required to travel the light in its path. So time equal to travel the light. That is Fermat's principle. So we will check is it correct or not. So according to Fermat's theory, the time required to travel the light is equal to t. So del of t should be equal to 0. So we have to prove. Let us consider, according to Fermat's theory, time required to travel the light in any particular path, the time should be minimum. So we can tell that del of t should be equal to 0. Let us consider one plane that can divide two different medium. So we just check this principle using the phenomena of reflection. So we know that what is reflection? We know that if the light travel from one medium to another medium and falls on a interface between two medium, and then if the light again go to the first medium, then this phenomena is called reflection. So let us consider AO is incident ray and OB equal to reflected ray. So AO AO is incident ray and OB is reflected ray. And we have to prove that this path OAOB should be minimum path to travel the light. So let us consider another path. Let us consider another path A O dash B. It can we can keep the initial point and final point should be constant. So we fix that point A and B, and we take another path A O dash B, A O dash B, and we have to prove that the real path followed by the light AOB, that is minimum possible distance that traveled by the light. So we have to prove basically AOB should be lesser than AO dash. For that case, we enlarge this OA up to point C, where we take this OC as equal to OB. So if we construct a triangle BOC, for BOC, we know that OC equal to OB, and these are 90 degree. So we can say that this triangle and this is the common arc. So we can say that these two triangles are equivalent. So we can write that AOB equal to AO plus OB equal to AOC, AO and C, as OB equal to OC. So we can write this. Again, if we consider this triangle for, we enlarge the O dash, we just connect the O dash and C. So we can see that the O dash B equal to O dash C according to picture, and O dash M is the common arc. And so we can tell that O dash C equal to O dash B equal to O dash plus O dash C, O dash plus O dash C. So for, if we consider the triangle AO dash C, for this triangle we can say that AO dash plus O dash C should be greater than AC, AOC. So now we see that from that equation number 1, from this equation we put this data AO dash C greater than AOC. So we can prove that any path rather than this AOB should be greater. So light should travel along AOB. This is the Fermat's theory, and we prove that this theory. Next one, we have to see, we have to make relationship the angle, incident angle and reflected angle. We have to establish some relationship, and we have to know the concept of reflection using the Fermat's principle. So if we see the reflection of light, let us consider the intersurface of two medium, that is first medium and that is second medium. If light falls from medium 1 on the interface of two medium, after that if it goes back to the medium 1, that is called reflection of light. So we can tell, or we can show that two formula of reflection. One is the incident ray, consider AO, and reflected ray, consider OB. According to formula of reflection, we show that the incident ray reflected ray and this perpendicular OC should be present in a particular plane. But if they are in different plane, then obviously the time required to travel of the light should not be minimum. To maintain this condition, we have to take this. We have to take this condition. Incident ray, reflected ray, and OC should be present in a particular plane. Second one is, if I consider that is a incident angle, and if I consider that if it is a reflected angle, we have to prove I equal to R. How can I prove? Using this Fermat's principle, we can prove easily. So we have to show this thing. So let us consider this line and this line, and take it is M and it is N. What should be the length of the incident ray? OA should be, if I consider AM equal to H1 and BN equal to H2 and OM is equal to X and ON equal to A minus X. That means AM equal to A, MN equal to A constant. Take MN as a constant A. So if we take that is X and that will be A minus X. So what will be A will be H1 square plus X square, and what will be OB equal to H2 square plus A minus X square. You can think that according to Fermat's principle, time should be minimum. If time is minimum, then we can tell that distance also should be minimum. So the total distance traveled by the light should be equal to AOB equal to, we just remove this thing, AOB equal to root over H1 square plus X square plus H2 square plus X square, A minus X square. This part will be minimum, so we have to differentiate this with respect to X. So if we tell it is S, so ds dx, ds of dx should be equal to half of H1 square X square dx plus half of H2 square A minus X2 square into minus of A minus X. Will be equal to 0. So what is X by root over A square plus X square? X by root over means OM, you can tell that OM by OA minus ON by OB equal to 0. So what is ON by OA? ON by OA. If it is I, then we can tell that is 90 minus I. So for this case, it will be cos of 90 minus I. Cos of 90 minus I. And what will be this one? This will be cos of 90 minus R. 90 minus R. So from that case, we tell that sin I equal to sin R. So I equal to R. So this two formula of reflection we can prove using the Fermat's principle. This is the benefit of Fermat's principle. And next one is rectilinear propagation of light. What is the rectilinear propagation of light? We can say that if light travels for a case of reflection, if light travels along A, O and B, so incident ray will be AO and reflected ray will be OB. If we transverse this phenomena, such as if OB is the incident ray, then OA should be the reflected ray. So if we transverse this phenomena, so the position of the ray should be invariant. This is the rectilinear propagation of light. So again we can prove the formula of refraction using the Fermat's principle. So we have to at first see what is refraction. What is refraction? Refraction is a phenomenon where light travels from medium 1 and falls on the interface between two medium, and then it travels in the second medium. This phenomenon of light is called refraction. So what happens in this refraction? We can get one incident ray and one refracted ray, and we tell that is the incident angle and that is the refracted angle. And we can prove the refraction formula of refraction using the Fermat's principle. So we want to prove this thing. For that case, we have to know what is the optical path. What is the optical path? To know the optical path, we have to know the refractive index. Refractive index of a medium, basically the ratio of the velocity of light in air medium and the velocity of light within a specific medium. So consider in specific medium the velocity is v, and we already know that in air or in vacuum the velocity of light is equal to c. So if we take time is constant for both cases, so we can write equal, we can multiply ct and vt. So we get LA by LB. What is L? The length travelled by the light in air, that is L, that is represented by Ct, and LB is the length travelled by light within a particular medium. So from that case we can tell that LB equal to mu into LA. That is the optical path. Optical path. So why we require this optical path? If the light travels from, consider light travels from air and travels after refraction, it travels through the water or glass. So we know that the light for a particular time light travels different length in different medium. So how can we compare this length for different medium? So for that case we have to assume what path light can travel within the air. So this is called the optical path. So for refraction we have to calculate this optical path. That's why I tell this thing. Let's go to prove the refraction formula. Here also A, O, B. AO is the incident ray and OB is the refracted ray. And let us consider the refractive index of first medium is mu1 and refractive index of the second medium is mu2. So for first theory of refraction is the incident ray and refracted ray and the perpendicular of this plane of this interface should be present in a particular plane. Why? Because we know that from the Fermat's principle we know that the distance required to travel by light should be minimum. So that should be the minimum path. Otherwise the path should not be minimum. And second theory is sin I by sin R should be equal to mu1 to mu2 or mu2 by mu1. So we have to prove that sin I by sin R equal to mu2 by mu. So using this Fermat's principle we have to prove this. So at first we have to calculate the optical path AOB equal to AO plus OB equal to AO means if we consider that is H1 and that is H2, then AO equal to H1 square plus X square. If it is X and that is this length is A minus X, then it will be H2 square, sorry, mu into that will be mu1 to mu2 into H2 square by plus A minus X whole square. So if we consider that is S, so ds by dx or ddx of S should be equal to mu1 by root over H1 square plus X square into 2x minus mu2 into 2 into H2 square plus A minus X whole square into 2 into A minus X. So 2 to cancel, so mu1 into, if it is I, then we can consider it 90 minus I. So x by OA, x by OA means cos of 90 minus I equal to a minus mu2 into, that will be cos of 90 minus R, that will be 0. So we can tell that mu1 into sin, so x by root H1 square plus X square, that should be cos of mu1 into cos of 90 minus I minus mu2 into, that will be 90 minus R cos of 90 minus R. So we can write that mu1 into sin I equal to mu2 into sin R. That is the formula of diffraction. So using the Fermat's principle, we can prove the formula of diffraction as well as reflection. So this is the all thing about today's class. So we will see another class. Then we will discuss about the matrix method of light. Okay, good night.